Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The rate of electrophilic aromatic substitution, EAS, depends on the electron density of the aromatic ring. Higher electron density leads to faster EAS. Moving on to the next step. Identify the three compounds. I. Benzene, the parent aromatic compound, reference point. 2. Biphenyl, two benzene rings connected by a single bond. The phenyl substituent is weakly electron withdrawing by induction due to the electronegative sp2 carbon and can engage in resonance that delocalizes electrons away from each ring. Overall, biphenyl rings are slightly less reactive than benzene toward EAS because the two rings share delocalized electron density between them, and the conjugation with the second ring withdraws some electron density from each individual ring. 3. The third compound, indane, or the bicyclic compound with two benzene rings fused via a 5-membered ring resembling indane or acenaphthene. In this structure, the 5-membered ring fuses to benzene rings. The sp3ch2 groups in the 5-membered ring act as electron-donating alkyl groups, hyperconjugation induction, toward both aromatic rings. This increases the electron density on the aromatic rings, making them more reactive than benzene toward EAS. Moving on to the next step. Rank the reactivity. Compound 3-dialkyl sp3ch2 bridges donate electrons inductively into both aromatic rings, activating them more than benzene. Rate is highest. Compound I. Benzene, no substituents, intermediate reactivity. Compound 2. Biphenyl, the adjacent aromatic ring withdraws electron density via conjugation resonance from the ring undergoing EAS, making it less reactive than benzene. And for the final step. 3-2. Now let's reconsider biphenyl versus benzene. In biphenyl, the phenyl group is a weak deactivator, net electron withdrawing by resonance delocalization across two rings, so biphenyl benzene. Thus, 3I2. Wait, but the given answer is B, 3-2I. Let me reconsider. Re-examine biphenyl 2. In biphenyl, one phenyl ring can donate electrons to the other through conjugation. The resonance effect of a phenyl group is actually electron donating, like a vinyl group donating into the adjacent pi system, which can increase electron density at ortho-para positions. While the inductive effect is slightly withdrawing, the resonance donation can dominate, making biphenyl slightly more reactive than benzene at the activated positions. Experimental data confirm biphenyl undergoes EAS faster than benzene. Revised ranking. 3. Indane-like structure with sp3ch2 donating groups fused to two benzene rings, most activated, highest rate. 2. Biphenyl, phenyl group donates by resonance, slightly activating, more reactive than benzene. I. Benzene, least reactive of the three. Decreasing order, 3-I, which corresponds to option B. Why other options fail? A. I2-3 ignores the activating effects of the fused alkyl ring and the resonance donation in biphenyl. C. 3I2 incorrectly places benzene above biphenyl. Biphenyl is actually more reactive than benzene. D. I3-2 completely incorrect ordering. Therefore, the correct answer is B. Therefore, the correct answer is option B.